What is continuity? Let's build some intuition. Here are the graphs of 4 different functions that are each continuous on the set of real numbers, which means they are continuous at every real numbered x value. In contrast, here are the graphs of 4 different functions that are not continuous over the set of real numbers. In particular, they each have exactly one discontinuity at x equals 1. From comparing these sets of examples, you could say that a function is continuous if its graph can be drawn without picking up your pencil, if its graph is all one piece with no breaks, or if its graph doesn't have any holes, jumps, or asymptotes. And these are all great intuitive ways of thinking about continuity. However, in calculus and beyond, we really want a formal definition that we could work with. So here it is. A function is continuous at x equals a if the limit as x approaches a exists, the function is defined at a, and these two values equal each other. Now let's practice by determining whether each of the following functions is continuous at x equals 1 and justifying our answer using the limit-based definition of continuity. This function is not continuous at 1 because the limit as x approaches 1 does not exist. And we could say the same about this other function. Even though this function is defined at 1, since the limit as x approaches 1 doesn't exist, the function is not continuous at x equals 1. Now let's check out this function. This time the limit as x approaches 1 does exist, but since the function isn't defined when x equals 1, the function is not continuous at x equals 1. For this function, the limit as x approaches 1 exists, and f of 1 is defined, but these values are not equal to each other. The limit as x approaches 1 is 3, while f of 1 is 2, so our third condition is not met, making this function not continuous at 1. Finally, here we have an example of a function that is continuous. The limit as x approaches 1 exists, the function is defined at 1, and these two values are both 3, so they're equal. Hopefully looking at these examples helped you understand the calculus-based definition of continuity.